everyone, this is 2.3 projectile motion. As you can see from these pictures, projectile motion is a very common thing that occurs in sports, amongst other things. And you can see from all of these pictures, there's a consistent shape to projectiles. Projectiles can be balls, they can be people, they can be just about anything flying through the air, and they make this parabolic shape. So the reason why they make this parabolic shape is because the only force acting on the object once it is kicked or pushed or shoved is gravity, and it makes that particular shape. So we're going to consider a simple type of problem in grade 11. We're going to consider the top of the projectile moving down. So not the entire parabola, we're going to consider half parabolas. It simplifies our problem significantly. There are two parts to a projectile. There is the horizontal part and the vertical. So starting in the horizontal, there are no forces acting on the object once it is kicked, pushed, shoved, etc. So there is actually no acceleration horizontally. Once that ball or whatever it is, that object is no longer in contact with whatever creates the force, the only force that acts on that object is going to be gravity. So because there's nothing pushing it forward, there's no acceleration in that direction. Time is going to be the same in the horizontal and the vertical because, of course, when I throw a ball and it lands on the ground, it hits the ground no matter what I look at from horizontal or vertically, it'll hit the ground at the same time. So in the vertical, gravity is going to be 9.8 meters per second squared down. That's a constant, and that's its acceleration. And just as I mentioned, the time will be the same in both the horizontal and the vertical components of projectiles. When we're solving problems, we want to read each problem and place the information that we see in either the X or the Y direction. So we're going to consider each piece of information. We're going to decide, is this something that's happening in the X direction, or is this something that's happening in the Y direction? Some things that we can all automatically put into our table because they're always true is that A in the X direction is always 0 meters per second, as we mentioned, 0 per second squared. So we could put the direction as forward here. The other part is A in the Y. Let's give these little guys some half arrows here. A in the Y is always a constant as well. It's 9.8 meters per second squared down. So we can put those automatically into our XY table when solving projectile motion questions. The other thing that's true is that V1, initial velocity, in the Y direction will always be 0 meters per second down. And that's because initially there is no movement in the vertical for that object. Gravity then takes a hold of it and then starts to accelerate it to a final velocity. To calculate unknown values in each problem, we're going to use those constant acceleration equations that we learned in lesson 1.5. So let's have a look at a problem so that everything has a context. So problem number 1, a cannon shoots a cannonball horizontally off the top of a cliff with an initial velocity of 35 meters per second. The cliff is 18.6 meters high. If air resistance is negligible, calculate the following. Part A, how long is the cannonball airborne? Part B, what is the horizontal range of the cannonball? This means what's the horizontal displacement? And C, what is the velocity on impact, both in the horizontal and the vertical? On impact means we're solving for V2 here. And again, when we're looking at horizontal range, we're looking at displacement in the horizontal, so being X, and then how long is it airborne, we're looking for T. So that's what we're going to solve for. So we're going to go back to the problem and we're going to pull out the information using the guess method. So we're going to set up our XY table, and the first thing I always do is I put in those values that are always known. So A in the X is 0 meters per second squared. A in the Y is always 9.8 meters per second squared. For direction, I'm just going to be general about it, and up at the top, I'm just going to write that the X is forward and the Y is down. I'm also going to put my V1X in. Actually, I lied. I'm going to put my V1Y in first, since it's always known as 0 meters per second. Now I'm going to go back to the word problem. Then I'm going to pull out the information for V1X, and that is given as 35 meters per second. And then I'm going to also pull out the other number that was given, which is delta D in the y. The hill or cliff is 18.6 meters high. So the first part of the question asks me, what is the time? Time can go into both areas. And when I consider this problem and how to solve it, because time can be an x or a y, I can use either the x values or the y values to solve for time. In this case, what would be easier? If I look at the number of items I've got, the y is the approach that we want to use because there are way more values in the y than there are in the x. And once I have it in the y, I also have it in the x anyways. So what I'm going to do is I'm going to choose one of my equations from my 5 acceleration equations to see what would work if I have an a v1, and a d, and I'm looking for t. So this is the equation we want to use. We want to use an equation that has nothing to do with v2 because we don't have any content about v2. The other thing that I can do before I start, and you can choose to do this or not, is anytime you have zeros in the y, remember we're only going to use the y values to solve here. You can't mix and match. If I have a 0, which I do, if I put that 0 in here, that means the whole thing, 0 times anything, is 0. So that allows me to simplify my question. And you can go ahead and do that now, or if you want to substitute and realize, oh, there's a 0 there, that's another option as well. So I've got a fairly simple equation now, and let's put in what I know. So I have 18.6 as my delta D, and then my acceleration is 9.8. My delta T squared is unknown, and it's divided by 2. So I've got to do a little bit of rearranging here. I want delta T to be by itself. Remember to keep it simple. So I'm going to bring the 2 over. Right now it's dividing, so it's going to end up multiplying. The 9.8 is multiplying the delta T, so when I bring it over, it's going to divide. Let's have a look. So I've got 18.6 times 2 divided by 9.8 equal to delta T squared. Now, of course, I want delta T to be by itself, so the last thing I'm going to do is I'm going to take the square root. So if I square root both sides, I can do that now or later. That'll get rid of the 2. And let's come up with a final answer here since I'm running out of space. So my final answer for delta T should be 1.9 seconds. Again, I'm going to bring that back to 2 significant digits. Even though the 0 is only technically, I guess, 1 significant digit because it's given, 0 is an exact value here, which means 0.000 to infinity. So really what I'm going to be using is that 9.8 and that 18.6. The second part of the question says, what is the horizontal range of the cannonball? So what is the horizontal displacement? So what I've done is I've gone back and I've put all the variables back into my XY table here, and I've also included the t's now because of course I can use them. And in this particular case, I am trying to find the delta dx. So the delta dx has to go under the x category. That should be pretty obvious, I think, since it's an x and I'm looking for x's, which means when I'm solving this problem, I'm only choosing from the x. So I'm using this information only. I can't mix and match. So again, it's time to go to those equations and decide which one can I use. And it just so happens it's the same one I used the last time. Again, one thing I like to do is say, okay, are there any zeros in here that I can simplify my equation? And there is. A is 0, which means this whole thing is going to be 0. A times anything is going to be 0. So this simplifies my equation significantly, which means this is really nice and easy. I don't even have to rearrange. So my V1 is 35 meters per second. My time is 1.9 seconds. So when I calculate that out, it's going to give me 67 meters. And I'm going to put that direction back in now as forward. And that's my horizontal displacement. Last part of the problem, again, I'm starting with that XY table. I've included the times again. I've also included my dx because, again, this is all information that I get to use. So this question says, what's the velocity on impact in the horizontal and the vertical? So that means I'm looking for v2x and v2y. Let's start with v2x. Remember that the acceleration in the horizontal is 0. So if I started with 35 meters per second and I did not accelerate, what would that mean v2 would have to be? Well, v2x is equal to v1x since a equals to 0. So v2x equals 35 meters per second forward. So that part is the easy one. There's no acceleration, so from a horizontal point of view, I can maintain the same velocity. The one that's going to be more challenging, not really challenging, but the one I'm actually going to have to calculate is in the y, because I start with no velocity and I'm going to accelerate towards the ground as gravity pulls on it. So that's what we need to calculate. So again, I'm looking for an equation that's going to meet my needs, and because I have all the variables, it doesn't really matter which one I choose. However, I would choose this equation because then you don't have to rearrange the problem, which is one less step and one less place to go wrong. So always, if you can, that's the way I would solve for things. Again, there's a 0 here, so I can see that I don't have to actually put anything in for v1, which simplifies my equation a little bit. Let's substitute and solve. So I'm going to have 2 times my 9.8 and my displacement, and then I'm just going to put it all together as 19 meters, and we'll put that direction back in for down. All right, problem number 2. This one you're going to try on your own, and then you're going to play the video to see how you did. So a golf ball is thrown horizontally with an initial speed of 6.85 meters per second forward from a cliff. Air resistance is negligible. This just helps us simplify the math. Determine the horizontal and vertical components of displacement and instantaneous velocity at a time of 3.12 seconds. So let's set up our XY table and put in the 3 values that are always consistent. So my AX is 0, my AY is 9.8, and my V1Y is 0. Now going back to the problem, let's pull out the numbers and include them where they belong. So the first one, V1X, was given as 6.85 meters per second forward. They also told me a time, and time, remember, can go in both categories. So time is 3.12 seconds here. Whoopsies. I don't really need to do delta time, although I could. Time is 3.12 seconds here. So I can use that time, although they've told me it's an instantaneous time, we can assume that that's the time where we're going to figure out some values based on it. So the first part of the question just asks us to figure out the dx and the dy. So dx equals question mark and dy equals question mark. So again, if we're solving for dx, let's do that one first. That means I have to pull from information from the x category. I don't get to cross over, as you recall. So step number 1, find an equation that's going to work. And it's that one we've used before, delta dx. Actually, I'm going to change my font here. Let's make it yellow. Delta dx is going to equal my v1 delta t plus a delta t squared over 2. Again, I can look for any zeros. That acceleration is a 0, so again, we get to simplify, which is nice, and then I can substitute in and solve. So my substitution looks like this, and my final answer is 21.4 meters forward. The second part, we're going to look at that y. So again, we're going to choose an appropriate equation, and we can actually use the exact same equation, substitute and solve. So I'm going to use the same equation. Again, I can go back and see if there are any zeros that will simplify, and v1 is a 0, so that means that whole thing will become 0, and then I can substitute in. So I've got my 9.8, my 3.12 has to be squared, and then I'll divide the whole thing by 2. That's an ugly looking 2. And I should get a value of 47.7 meters down. So in the second part of the question, I'm looking for V2x and V2y. Just like in the last problem, V2x is equal to V1x, which is equal to 6.85 meters per second forward since acceleration is equal to 0. My velocity will not change. My v2y, however, again, I'm going to use that same equation I used the last time for simplicity. This way, again, I don't have to rearrange my formula, which is always handy. And my v1 is a 0, so also handy. So now I can just substitute and solve. So my final answer is 30.6 meters per second down. And again, you'll remember from our 1.5 lesson that a number like 2 as part of an equation is not a significant digit. It's based on given values. So your homework today is on a worksheet, and it is part of the D2L website.